Okay, this question is a little bit tricky. First of all, there is a hot air balloon which is 100 feet above the ground, and we have a motorcycler passing through just beneath of it. Okay? At that time, t equals 0 or something like that. Okay? And the speed of it is 40 miles per hour. So be careful. The units are different right now. Okay? So it's because it's a real life situation. So 150 feet above the ground, that's the place of balloon. But the speed or the velocity of the motorcycle is 40 miles per hour. So that's I give you the real number. So let's say it's traveling this way, because it's positive direction, x right there. So the position of x is position of motorcycle, and that's the distance from that over there. Then it giving us dx dt, right? And you have to choose one common units for both, right? Feet or mile, but everything is about feet and second, so it's better to change that 40 miles per hour to feet per second, and which is given, which is 58.67 feet per second. Okay, I'm sorry about that number, but okay, then it asking the balloon is rising vertically. Okay, so let's say that is distance, so y, and going up. So dy dt is rising up feet per second, 10 feet per second, right? Okay? So everything is about feet. Okay, that's good, and that's the situation. And it's asking what is the rate of change of distance between the motorcycle and the balloon. So they're asking this distance, and because of direction, that distance will increase, right? So before doing anything, what they're asking us dt, so let me change that one. So distance is, let's say, z. Okay, so they are asking what the z dt is, of course, by feet per second. Okay, then we need a formula including z, x, and y all together. Okay. And it doesn't giving us at the specific position of x or y, but it's just giving us time after 10 seconds later. So when t equals 0, the motorcycle position was just beneath the balloon, right? So x equals 0. So 10 seconds later, where the x is, the speed of x is like that. So 10 seconds later, the position of x must be when 10 equals 10, t equals 10, then x must be 586.7 feet. Okay? That's the position. Then from this right triangle, once again, we know that z must be square root of x squared plus y squared. Okay? Then be careful, when time t equals 0, x was 0 and y was 150. So when 10 seconds later, x is changing that much and y is also changing, because the rate of changing of y, the balloon, is 10 feet per second. So after 10 seconds later, it must be 100 feet above the original position. So 150 times 100, right? So that's the position at the time, right? So 250 feet. Okay? That's the position of y, okay, at the time, like this eventually. So that's the all information we need to figure out. So it's a little bit tricky. So from that equation, dz dt, that's what we are looking for, is by that square root formula. It's gonna be like that, and derivative of whatever it is, right? So it's going to be 2x dx dt and 2y dy dt, right? So we have to put these xy's for every xy's like that, and we know what dx dt and what dy dt is, right? So for those two, must substitute those informations, and that's what we are looking for.